Hello everyone. Welcome back to the Math Mindset, and thank you for the 150 subscribers. And in this video, we have a challenge problem that deals with SAT geometry concepts. This is actually a math competition problem from the 1991 AHSME, which stands for American High School Mathematics Examination. And let's just get started, I guess. Alright, so this problem tells us that if ABCD is a square, a 2 by 2 square, and E is the midpoint of AB, F is the midpoint of BC, AF and DE intersect at I, and BD and AF intersect at H, then the area of quadrilateral BEIH is. Alright, so I'm going to redraw this diagram down here. So let's get our square. Oh, let me try that again. Hold on. So let me draw this square. Let me move this right here. Oh god. This is really painful. Okay. Let me try getting this perfect square down. Hold on. Oh my god, this is so difficult. Hold up. Alright, that's good enough. Right. So this is A, B. Right, is that how it's named? Oops, my bad. So this is B, this is C, and this is D. Right? And what else do we have? We have E is the midpoint. We have E as an F midpoint. And I'm pretty sure we also have F as a midpoint. Okay, and then we'll draw lines AF and DE. So that line, oops. That one. And then we'll draw line BD as well. Oops. Man. Okay, there. And then we also have to... I think that's it. Right, that's all the information we have. Alright, so let's mark some of the sign lengths that were given. So we know E is a midpoint, so that side is 1 and that side is 1. BF is 1, FC is 1 because F is a midpoint, DC is 2, and so is AD. Right, and we want to find the area of, what do you call it? This quadrilateral, right here. This is what we want to find. So we want to find the area of quadrilateral BEIH, right? Yep, that's about right. So this is I, and this is H, right there. And basically how we're going to be solving this problem is we're going to be using similar triangles, right? If you notice, this quadrilateral that we're talking about is completely contained in this right triangle. And we have to subtract off the area of these green portions to get the area of our desired quadrilateral. So I'm basically going to write an equation. The area of BEIH is equal to the area of triangle ABF minus the triangle of BHF minus the area of triangle AIE. Now we know what the area of triangle ABF is. It's a 2x1 right triangle, so that means its area is 1. So that means ABF is 1. Then we just need to subtract the area of the other two triangles. So let's tackle finding the area of triangle BHF first. So we want to find the area of triangle BHF first. So what is the area? Right, we look at triangle BHF and we notice that it's similar to this triangle that I'm going to draw in yellow. Right? Oh, what happened? I accidentally clicked on the picture. So it's similar to triangle BHF is similar to triangle AHF. So it's similar to this triangle right here. Because these two sides are parallel, right? Some angles will be the same, and that's how we know they're similar. All right? So we know that, let me just write it down. Let me just write it down here. Hold on. I'm just going to write it down. Triangle BFH is similar to triangle ADH. And we want to find the area of triangle BHF. So how will this help us? Well, let me draw the altitudes of the two triangles. We'll call this altitude H1. And we'll call this altitude, here, I'm going to say H2. Like that. And because we know those two triangles are similar, right? We know that H1 over H2, right, will be equal to the ratio of corresponding sides of the corresponding triangle. So it'll be equal to, here, let me just write this down. So you have to get a side from the bigger triangle that we know. So it'll be equal to AD, which is the side of the bigger triangle, and its corresponding side, BF. We know it'll be equal to that. And AD over BF is just 2, right? So what do we know from this? We know H1 is equal to 2 times H2. And we also know H1 plus H2, right? That's equal to 2. So if we solve for H2, we get 3H2 is equal to 2. So H2 is equal to 2/3. So we know what the height of, or the altitude of triangle BHF is. So we can erase this and say that's 2/3. Oops. God. Okay, yeah, we can say that's 2/3. And then we can erase this and say that triangle's altitude is 4/3. Right? So now we can calculate the area of triangle BHF. Right? The area of triangle BHF is just 1 times 2/3 divided by 2, which is 1/3. So it's just 1 minus 1/3, right? And then we also have to find the area of triangle AIE. Like that. So we have to find the area of that triangle, and then we'll be good. So let me actually bring this diagram down. Let's see here. Let me get this. Hold on. Let me bring this entire diagram down. Down, right there. Okay, there we go. Let me just rewrite some parts of this. Okay, great. So now we want to find, what do you call it? The area of triangle AIE. And once we find that, we'll be able to subtract 1/3 and the area of AIE from 1 and get our answer. But how will we find that? Well, again, let's try using similar triangles. So we have our triangle here, triangle AIE, right? Do we see any triangles similar to that in the square? Well, no. Can we make one? Yes, we can. If we extend side AF and DC until they meet, we have, and call this meeting point X, right? We have similar triangles, right? We have triangle AIE, triangle AIE is similar to triangle DXH. Those two triangles are similar. Or, sorry, not DXH, DXI. Oops, this is supposed to be I. Right? Because they meet right here, point I. Alright, so now our one challenge is to find the length of CX. Well, lucky for us, we can already do that. Because we know triangle FCX is similar to triangle ADX, right? This small right triangle is similar to the bigger one, that one, right? We know that. So that means FC over AD will be equal to CX over DX, right? So FC over AD is just 1/2. And CX we don't know. We know how to write DX in terms of CX. DX is just CX plus 2, right? And so we get 2CX equals CX plus 2. And that means we get CX equals 2. So we know what CX is. We know what CX is. It's just equal to 2. Right? Let me write that there. It's equal to 2. Now we go back. Right? We go back to this similar triangle ratio. Let me bring this here and examine it a bit further. Right? Now we can focus on this because we know all the dimensions of both triangles. Well, not all the dimensions, but the required dimensions on both sides of this triangle. right? And let's keep in mind that we want the area of triangle AIE, right? So the area of triangle AIE over the triangle of DXI will be equal to AI over DX squared. Now this is just the property of similar triangles. If two triangles are similar and they have a ratio k, then the ratio of their areas will be k squared. And since we know what AI and dx are, that's what we're using. We know AI is 1 and dx is 4. So the ratio of their areas will be just 1 over 16. So 1 over 16 is the ratio of the area of triangle AIE to DXI. Right? And now we get one step closer to finding the area of triangle AIE. But first, we need to categorize what exactly counts as the area of DXI. Right? We have this little triangle here. This is 1. Right? Actually, yeah, that's 1. And we know the area of triangle BHF is 1. So the area of this trapezoid FHDC will be equal to 2 minus 1/3, which is equal to 5/3. Let me just erase the height and write that down there. Let's see. We know the area of this trapezoid is 5/3. Right? And the area of DXI also includes this slender triangle right here. Now we can actually write that triangle in terms of the area of BEHI. So if I let this area equal x, right? If I let the area we want equal to x, then this triangle has area 1 minus x. Because the entire triangle BED has area 1 because it has a base of length 1 and a height of length 2. Right? So that's just 1 minus x. So we can add that all up and write that. So the area of triangle AIE over 5/3 plus 1 plus 1 minus x, right? The triangle of AIE is just, what is it? It's 1 minus 1/3 minus x. So 1 minus 1/3 minus x, right? This is just equal to 1 over 16. And we can solve this proportion. We get 2/3 minus x over 11 over 3 minus x is equal to 1 over 16. And so we get 11 over 3 minus x is equal to 2/3 minus x times 16. We get, here, let me see. This is equal to 32 over 3 minus 15x, or sorry, minus 16x rather. Minus 16x, and this is equal to 11 over 3 minus x, right? And we can add 16x to both sides. And we get, what do you call it? 11 over 3 plus 15x is equal to 32 over 3. Subtract 11 thirds from both sides. We get 15x. Here, let me rewrite that. We get 15x is equal to 21 over 3. And this is just equal to 7, right? And so we get the area that we want, x, is just 7 over 15. And that's our answer. And I believe that's answer choice C, right? Yep, and that's our answer for this problem. Well, I hope you enjoyed this challenging math problem exercise that we went over today. We used the concepts of similar triangles and we constructed similar triangles in order to be able to find for the area that we wanted. So just to recap, we wanted the area of this trapezoid here, BEIH, and to do that, so we wanted the area of this trapezoid here. And to do that, we subtracted off the areas of this triangle and this triangle using similar triangle properties to find our answer. And that answer turned out to be C. And that's our answer. Hope you enjoyed this video, and please don't forget to like, share, and subscribe. And I'll see you in the next one. Goodbye.